this device, the first device which we are going to study is that diode. So what is a diode? First, let's define it. A diode is a device which passes electric current only in one direction. No electric device does this except diodes. For example, in a resistor, electric current can go in both directions. In a capacitor, you can charge it in positive and negative in both ends. But diode passes electric current only in one direction, and direction of this is the symbol of the diode, and direction of the arrow represents in which direction electric current is going. So the arrow indicates the direction of the current in the diode. As you see, this arrow shows from left to right. This tells you that this diode lets electric current from left to the right, but not from right to the left. So it has nearly zero resistance in the direction of the arrow. In the direction of the arrow, resistance goes to zero. Of course, as resistance goes to zero, electric current goes to maximum, or yes, electric current goes to maximum. So it lets electric current in one direction, but in the opposite direction of the arrow, it has almost infinite resistance. Yeah, the resistance goes to infinity. As resistance goes to infinity, electric current goes to zero. Yeah, electric current is zero in the opposite direction of the arrow. Electric current can be allowed to the right, but does not allow to the left in this diode. But how can a diode do that? What is a diode? First, how can we construct a diode? Now we will talk about this. And a diode can be constructed by using a p-type semiconductor and an n-type semiconductor. In p-type semiconductor, holes are mobile charge carriers, but electrons are immobile. In n-type semiconductor, electrons are mobile, but positive charges are immobile. Then we are going to combine them and form a p-n junction diode. Let's combine and see what happens. When we combine this p and n-type semiconductor, so the border which they combine is called the junction. This border is junction. This is called p-n junction. P and n meets each other and makes a p-n junction. As soon as they combine, we know that holes are mobile in p-type. Electrons are mobile in n-type. So electrons and holes, they are oppositely charged particles. They will attract each other. And these electrons and holes will start combining in this region, which is junction. Mobile holes from the p-type and mobile electrons from the n-type migrate. Migrate means move across the junction. Yani one of them goes to the right, the other one goes to the left, and combine. But when they combine, one positive, one negative, cancel each other. And they meet, but they cancel each other. So they, in fact, destroy one another by combining. So this hole will combine with this electron, they will destroy each other. This hole and this electron will destroy each other. That hole and this electron will destroy each other. Initially, there were equal number of positive and negative charges in this p-type, but now positives are destroyed. This layer becomes only negatively charged. This layer becomes only positively charged. So two layers will be formed when we combine them. One layer becomes negatively charged, which happens in the p-type semiconductor, and one layer becomes positively charged, which happens in an n-type semiconductor. And we know that electric field forms from positively charged layer to negatively charged layer, just like electric field between two parallel plates. Positively charged parallel plate to negatively charged parallel plate. Electric field forms. This region in which electric field forms is called depletion region. Depletion region. So the region in which electric field is formed called depletion region. So negatively charged layer, P layer, positively charged N layer forms a region of internal electric field and also potential difference. Potential difference, because we know that negatively charged layer will have a low potential because negative has a lower potential. Positively charged layer will have a high potential. And what is the difference between them? Is there a difference between them? Yes. Also, there will be a potential difference between the positive and negative charged layers, which is called potential barrier. Why is it called barrier? You will understand it next. So, when this electric field forms, but there are still some free electrons, mobile electrons on n-type, but there are still some mobile holes on the p-type. They also want to combine. Because their mutual tendency is to combine. However, we know that if an electric field exists, negative charge always have a tendency to move in the opposite direction of electric field. Positive charge have a tendency always to move in the same direction of the electric field. Now look at that. To combine this hole and this electron must move to the left. Yeah, in the same direction of electric field, but this is not the tendency of an electron. This hole must move to the right, but it's in the opposite direction of the electric field. It's not tendency of the positive charge. That's why this electric field blocks, stops further combination of electrons and holes. This electron and this hole cannot combine anymore. Why? Because this electric field stops that. Because we know that electrons cannot move in the same direction of the electric field. Positive charge cannot move in the opposite direction of electric field. So, they prevent any further location combination of mobile electrons and holes across the junction, and all charge flow stops quickly. As soon as this electric field formed, no more combination of holes and electrons. We can explain this by using potential electric field, it's okay, but there's one more explanation, potential difference. We know that electrons are moving from negative terminal of the battery to positive. Yani from low potential to high potential. Tendency of electrons are to move from low potential to high potential, but positives are not like this. Tendency of the motion of the positives are from high potential to low potential. But now look at that. Which point is low potential? Here. Which was high potential? Here. If this electron wants to combine with this hole, it must move from high potential to, but it's not its tendency. An electron never moves from high to low. It always moves from low to high. That's why this potential difference between these layers also stops further combination of electrons and holes. Yeah, by two ways we can explain this. In terms of electric field stops further combination of electron and holes. Second one is potential difference between these two layers also stops further combination of electrons and holes. That's why charge flow stops quickly as soon as this depletion region occurs or forms. So this is called a PN junction. This is a PN junction. And in a PN junction, there are three distinct regions. One of them is, as we see, depletion region. What is property of depletion region? In this region, there's an electric field. One side of the depletion region is positively charged, which is M-type. Other side of the depletion region is negative charge, which is P-type. And because mobile holes and electrons cancel each other, in here no mobile charge carriers. No mobile charge carriers. But there are two more regions. One region, half of P-type, still consists mobile holes. Other part is half of, or other part of N-type, which still consists some mobile electrons. And third region contains some mobile electrons. Second region contains some mobile holes. But first region, which is depletion region, have no mobile holes or electrons because we are combining. While they combine, they cancel each other. This diagram is my drawing. But your diagram is this. We should talk about this diagram again. There's a slight difference between them, that's why we have to know it. Depletion region we know. So depletion region have two layers. One layer is negatively charged. These negatives are fixed negative charge. They are not mobile. And also one layer is positively charged. These positive charges are fixed as well. They are not mobile. But these arrowed one are mobiles. They can move. Yani these holes are able to move while these electrons are mobiles. Yani shown by arrows. They can move. And depletion region is the region through which the electric field forms from P-N type to the P-type. And as I explained, negatively charged part of the depletion region has a low electric potential. Positively charged side of the depletion region has a high electric potential. If I represent how electric potential changes through a P-N junction. If I say that low is 0, he said 0, then from left to right potential is increasing. Look at that. Assume that in here is the potential is 0. Then when you go from left to right, it goes from negative to positive. It's increasing. That's why look at the arrow. Look at the graph. It is increasing and becomes maximum here. Then constant because in here equal number of positive and negative charges we have. In here, equal number of positive and negative charges we have. That's why here is straight line, here is straight line. But in depletion region, there is a big shift in potential difference. 0 to a big number. This potential difference is called potential barrier, which stops further combination of holes and electrons. Because holes to combine with the holes, to combine with electrons, they must move from low potential to high. It's not their tendency. For combine with the holes, electron must move from high to low. It's not the tendency of negatives. That's why this potential barrier stops combination of these mobile electrons and these mobile holes. So this is the P-N junction and P-N junction diode also. Then we will talk now, how can we make a diode, giving electric current or letting electric current in one direction, and how can we make a diode letting electric current in the opposite direction. Now we are going to talk about this. When a diode allows electric current in one direction, in the direction of the arrow. When a diode allows electric current in the direction of arrow, it is said that this diode is forward biased. Forward biased. What does forward bias mean? A diode lets electric current in one direction. Yeah, in the direction of the arrow. But how can we do that? How can we make a diode to be forward biased? Okay, you know that normally these holes and electrons cannot combine anymore because this has a low potential, this side has a high potential. What if I shift this potential difference by using a battery? I can shift it. I can use a battery. I know, battery has a positive terminal and a negative terminal. So, positive terminal, high electric potential. Negative terminal, lower potential. If I join, this is what now. If I join the positive terminal of the battery to P side, so I'm going to make here positive. This side becomes positive. It was low, but now I made it high. So normally this was high. If I join negative terminal of the battery to N-type, this becomes low. Did I change the potential difference? Yes. It was low and high. Now by joining and by connecting a battery, I make it high to low. Okay. High to low. Yes, it is the tendency of a hole. hole can move from high potential to low potential, and also these electrons can move from low to high. So by doing that, I provided again electric current. So if the direction of the internal electric field and polarization of the potential barrier is reversed, how can we do that? By using a battery. Mobile electrons and holes are allowed to combine. When they start to combine, of course, electric current will start flowing through the junction. So this is called forward bias.
So the direction of electric current there changes?
No, electric current again, direction of electric current is the direction of the motion of positive charge we defined before.
No, electric field.
Yes, electric field direction will change, of course, otherwise both potential and electric field direction will change. Because electric field is from positive to negative.
So whenever there is a change in the direction of potential difference,
exactly,
there's
a change in electric
current.
current. Exactly. But if you make a change in the potential difference, so there will be a change in electric field. Correct. So this is how we bias forward a diode. You have to connect positive terminal of the battery to P-type. Positive P, P. Negative terminal of the battery to N-type, N. Positive to P-type, negative to N-type. This diode is forward biased. It will let electric current. When a positive potential of the battery is applied to the P side, yes, positive is applied to the P side, and negative potential is applied to the N side. So electric field direction will shift, and also potential barrier will change. Thus, holes and electrons will start to combine again, and current will be formed. In this condition, it is said that diode is forward biased. It lets electric current. Now we know now how to make a diode letting electric current in one direction. But diodes are stopping electric current direction in opposite direction. How this happens? Now we'll talk about this. When a diode does not allow electric current, it is said that this diode is reverse biased. Reverse bias means does not allow electric current. Normally, at this situation, a PN junction has a tendency that no further combination of positive holes and electrons. If I join a battery so that this is normally low, this side is high potential. If I join negative terminal of the battery to P side, positive terminal of the battery to the N side, it was low. By connecting negative, I did much lower. It was high. By connecting positive, I did it much higher. So I increased the potential barrier even more. So, is it possible for them to combine? No. So if you connect negative terminal of the battery to P side, positive terminal of the battery to the N side of this PN junction, so this diode is said to be reverse biased. So when a positive external potential is applied to the N side of the junction, potential barrier is increased even more. This increase limits the current of in the junction. Such a diode is said to be reverse biased. This is what happens. Negative to P, positive to N. So potential barrier increased even more. Depletion region becomes more stronger and even wider. So no further combination for electrons and holes. Reversed biased. No combination of electron and holes. No electric current. Resistance of a diode is not constant. Resistance of a resistor is constant if you don't change the temperature. We know this. But diode is not like this. Diode has a variable resistance. In one direction, it is an infinite resistance. In opposite direction, it has Zero resistance almost. This diagram, this graph is representing how electric current and potential difference changes across a diode. Potential difference is given in horizontal, electric current is given in vertical axis. Yeah, y-axis is current, x-axis is potential difference. And there are two types of connection for diodes. One of them is reverse biased, the other one is forward biased. This side is reverse biased. If the diode is reverse biased, we know that electric current is zero. Yeah, if I draw the graph with red, so normal electric current in reverse bias must be zero, and it must be like this. Zero. But check it. It's not zero. A little negative, huh? A little negative. How about inside? When electric current is zero, what does resistance mean? How much is resistance?
No.
You know equation of resistance? V over I. If I goes to zero, resistance goes to infinity. Your resistance is too high when electric current goes to zero. So when the diode is reverse biased, the curve is near the horizontal, which means electric current is zero, which implies that resistance is infinite. But it's not just complete straight line. It's not just on x-axis. It's a little down. Then there's a small, very small, negative current exists. But what is this negative current? Where does it come from? The current is slightly negative means that in reality, a small leakage current still flows in the wrong direction of the reverse bias diode. What does wrong current? What does leakage mean first? Leakage, you know what leakage is. So there's a pipe in your house which gives the water to your house. So if there's a hole, it starts leaking. The leakage is this. And this is what we want, what we expected, but accidentally it happens. Leakage current is also like this. We want, for example, say that we want to stop electric current in clockwise direction. So we use a diode, we stop it. We stop the electric current in clockwise direction, but we observe that while we are stopping this current in clockwise direction, a leakage current exists in counterclockwise direction. This is leakage. Wrong direction means that. This is the reverse biased case, but diode can be forward biased as well. But in forward biased diodes, current potential difference graph is not linear. Linear means straight line. As you see, it's a curve. It's not like linear. It's a straight line. But it's a curve, not straight line. Straight line means linear, curve means non-linear. What does this non-linear graph tells you? You know, in mathematics you calculate the slope of a graph. Slope is delta y over delta x. And here delta y what? Electric current. Delta x, potential difference. Yani, in fact, this slope is telling you how I over V changes. How I over V changes. But we know that V over I is resistance, but I over V, 1 over R. Yani, in fact, this slope is defining 1 over R2. Now check the slope, how slope changes. As electric current increases, what happens to the slope? Slope increases. As electric current increases, slope increases. Yani, I over V increases. What does it mean? 1 over R also increases. But what about R itself? Decreases. Because if R decreases, 1 over R increases. What does it mean? As electric current increases, resistance of the diode decreases. No other electronic device can do that. Only diode. As electric current of the diode increases, its resistance decreases. When the diode is forward biased, the resistance changes, yes, and approaches to zero for large currents. For large current, it approaches to zero. Now, where do we use them? Diodes are very important because they are used to convert alternating current to direct currents. So diodes can be used to convert alternating current and direct current. This process of converting alternating current and direct current by using a diode is called rectification. rectification. That's why diodes are named as rectifiers. Next question. Which of the following is rectifier? A. Diode. B. Capacitor. C. Resistor. D. Transistor. Rectifier is diode. But how would I do that? This is an AC output of a generator. We know that. One positive, one negative, one positive, one negative. So positive, negative, positive, negative. Say that positive current is clockwise. Counter negative is counterclockwise. And you join this generator to a resistor, but there is a diode as well. You put a diode. You know that diode only lets electric current in the direction of the arrow. So when it is positive, say clockwise, electric current is L load because direction of the electric current and direction of the diode is same. L load. Then forward biased. For clockwise current, this diode is forward biased because direction of the electric current on the diode and arrow direction of the diode is same. Correct?
Yes.
And this positive is L load. But what does negative mean? Counterclockwise. When generator changes the electric current direction to counterclockwise, direction of the counterclockwise current and arrow is opposite. Yani this diode will not let counterclockwise current. Will stop it. Only clockwise, which is positive, will be L load, but counterclockwise, which is negative, will not be L load. So the diode is forward bias for positive pulses and reverse bias for negative pulses. The negative part of the current is suppressed, yani cropped. Crop. You know what is cropping? Cut. Suppressed by the reverse bias diode. Then this AC will change to a DC on the resistor. Only positive. Because negative is cropped, 0. Positive. Because negative is cropped, 0. Positive. This process is called rectification. We converted AC to one directional current. Remember in 6.2 we said it's a pulsating direct current. And here they said pulse direct current. Same thing, pulsating, pulse direct current. This is what only if we use single resistor, or single diode. Single diode converts AC to DC, just cropping the negative part and letting the positive part. Positive, positive, and so on. What if we use more than one diode? If we use more than one diode, we can do much better direct current. Single diode crops this side, but that two diodes inverts this negative to positive. So a smoother direct current can be made from an alternating current if more than one diode is used. An additional diode allows more pulses of the direct current. Yani it was normally negative, but two diode system can shift, invert this negative to positive. But in single diode, it was only cropped. So negative shifts to positive. Only we have positive pulses. 0, positive, 0, positive, 0, positive, 0, positive, 0, positive. Pardon. 0 positive maximum, 0 positive maximum, 0 positive maximum, and so on. The previous one was not like this. 0 maximum, 0, 0. 0 maximum, 0, 0. It goes on that way. Alright. So if you use two diodes or more than two is much better. 4 diodes, much better. And as number of diodes increases, you can make it much better direct current. But diode itself is not enough to make it much steadier. We are going to use one more device to make it steadier. If some capacitors, which are called filters, are included in the rectifier circuit, it smoothens the output of the rectifier. Smoothens. How does it do that? You know that capacitors are storing electric charge? Storing electric charge? Yes, they do. Now follow. When electric current is maximum, capacitor takes the charge, keeps the charge. But later electric current becomes 0. When electric current becomes 0, this time capacitor gives this charge back to the circuit and fills this here. Then when it becomes maximum, takes it. When it becomes 0, gives it. Maximum takes it, 0 gives it. So what happened to the electric current? It never becomes 0. It is not perfect straight line, but much better than the previous one. So it's what capacitors are used to smoothen the output of the rectifier, yani diode. Capacitor stores charge when the potential difference is applied and releases discharge when electric current is 0. So they keep the current in circuit steadier than on the diodes. That's why all chargers open them, you are going to see that inside them there are diodes and also capacitors are included. All chargers. First there's a transformer which converts 220 to 9 volt or 6 volt, how much is your charger is. Then output of the transformer, there are diodes and then capacitors, which makes a direct current. That's why all chargers are getting output current as a direct current.